Good morning, and today we're going to complete solving trig equations by doing one final example. And here we have another example here. We have our compound angle. Okay, so we have our 2x and we also have a wee shift left or right as well with our minus 30 here. Okay, so let's have a wee look at what we're going to do. Well, I've taken my negative root 3 over to the right hand side, made it a positive root 3. I'm now going to take my 2 over, which will make it a divide by 2. So we've got root 3 over 2. Okay. And now let's work out what that leads to as an associated acute angle. So to get the associated acute angle, we're going to do the inverse sine of root 3 over 2. We'll use our little triangle here at the bottom to help us. So what angle would we start with that would have an opposite of root 3 and a hypotenuse of 2? So we'll start with a 60, opposite of root 3 and a hypotenuse of 2. So the angle is going to be 60. Now when we look at our all sine tan cos diagram, that means we have a 60 in there. Okay, and we're dealing with a sine and we're dealing with a positive. So let's just remember what these quadrants are in relation to sine. So here we have a positive in the all and in the sine. It would be negative in the tan and the cos. So we're looking for it being sine and positive. So we want to tick the all and the sine quadrant, the first two quadrants. Okay, so we're then going to be able to say that 2x minus 30, because it was obviously 2x minus 30 is left when we do the inverse sine, is going to be 60 and 180 minus 60. Okay, so hopefully that makes sense. We're going to bring that over onto the next slide here, just as we had it there. So now we start to rearrange it. But before we start to rearrange it, let's just check how many cycles we should have. Okay, so we need to check if we should have any extra answers like we did before. Okay, when we had to look at the fact that we had a 2x in there, which meant that we could actually, remember a 1x means that we could have up to 2 answers. That's what we did at National 5. But if we've got a 2x, it means that we could actually have up to 4 answers. We want an answer between 0 and 360, so we're expecting up to 4 answers here. Okay, so 2x means 2 cycles of the graph up to 360, so we're expecting to get 4 solutions. And just a wee check here as well, especially when you've got a shift, see because of that negative 30, just do this check very carefully. When we've got a shift, that means that the graph has been shifted left or right 30 degrees. Okay, if it's a negative, it's been shifted into the positive direction 30 degrees. But sometimes it can go the other way. So we've got x between 0 and 360, but here we've got a 2x minus 30. So that means that from this, we want to see what the 2x minus 30 line should be between. Now 2x minus 30 means we're timesing the x by 2 and we're taking away 30. Times by 2 take away 30. So do that for each of these numbers as well. Times by 2 take away 30, that leaves you with minus 30. Times by 2 take away 30, leaves you with 690. So at the 2x minus 30 line, we want our answer to be between negative 30 and 690. So we can see here we've definitely got some cycles to add on. But the reason I'm showing you this is because very, very occasionally, and it would make it a harder question, if this was going back quite a bit further back into the negative direction, you might actually want to subtract 360 from some of these numbers to get something into that part of the answer there. So if you think answer looks as though it's not small enough to begin with, then that might be what you had to do, but that's very rare and it would make it a much harder aspect of the question. Very rare that that comes up though. Okay, so we can see here that if we were to do 60 minus 360, that would be too small, much lower than negative 30, and 120 minus 360, much lower than negative 30. So we're not subtracting any 360s here. But we've got to bring it up to 690, so we definitely want to add on a couple of 360s. So further solutions are going to be where we add on our 360s. So the next line is going to then be just to continue this line here, which is your 60 and your 120, and then your 60 plus your 360 and your 120 plus your 360. And again, if this wasn't just a 2x, but if it was a 3x, you would expect to have 6 cycles. If it was a 4x, you might have up to 8 answers, 8 solutions, okay? So you can just keep adding your 360s onto these if you think you haven't gone far enough. So here we've got 2x minus 30 is 60, 120, 420, and 480. And we thought the answer actually had to go up as far as 690. So if we just check, if we were to add on a 360 to that, it's too high. It's much higher than 690. So we don't add any more 360s on. Okay? So 2x equals, so the next thing to do is take the negative 30 and add it as a 30 onto each of the sides, onto each of these numbers on the right hand side. So add 30, add 30, add 30, add 30. Just rearranging that equation. If you just had 2x minus 30 equals 60, you would do 2x equals 60 plus 30. You just do it for each of them individually. Okay? So you get your answers to those. And then the last thing you'll do is just divide by your 2. So you've got a 90 divided by 2, and a 150 divided by 2, and a 450 divided by 2, and a 510 divided by 2. And those would be your answers. So here's your final answers here. And you look and just check x between 0 and 360. Yeah, that's fine. We didn't have to change it into radians, so that's fine. If you had looked and thought, I don't think I've gone far enough, if say you're nowhere near the limit there, if maybe the limit was going into the next cycle or whatever, 720, they wanted extra cycles brought into it or whatever, you don't add 360s on at this stage. You go back to the stage here, just after where you've done the inverse sine. Okay, when you've just used your all sine tan cos diagram to get your answers from your diagram, that's the stage you can add on your 360s, not any further down. It's always back to that stage there, if you have to. Okay, so that gets a bit more complicated again. A few questions to practice on that. Here we have exercise 4i. Now, I've picked out some questions for you, but there are some more if you want a bit more practice. You should at least do those ones, but if you can manage any more of them, then do so. You will get a bit more practice at solving trig equations in the next 2 topics that we're going to be doing, because they also involve trig as well. And you actually find that when you look up the past papers, the past paper questions that you see that involve you solving a trig equation actually involves one of the next 2 topics first. So you're not going to be able to tackle many past paper questions at this stage until you've done the next 2 topics, where you have to do a little bit of work on those trig equations to get them ready before you're ready to start solving them. Okay, so that's us finished this topic, but we are on to another topic which is involving trig equations, and we'll be going on to those 2 topics next. Okay, so ask your teacher if you need any help, and take care and good luck.